All right, everybody. So here's the rest of the lesson for today. We did talk about the variability and the center in class, but I'm going to go over it again. I'll zoom this in so you can read my writing and I'll also read it. For variability, I'm looking at a couple things. I'm looking at the interquartile range, the spread of the middle 15 or 50% of the data, and the min and the max. So Massachusetts has the most amount of variability in annual household income, and Maine has the least. Yes, it has this outlier, but the IQR is a little bit smaller than Connecticut, and without the outlier, we also do have a little bit less variation. So the statement would be something along the lines of Massachusetts has the most variability in annual household income. When I talk about annual household income here, that's the context I'm looking for, and Maine has the least. Like we talked about in class, you could say Massachusetts has the most or more than Connecticut, and Connecticut has more than Maine. That would work as well. For the shape, Maine and Massachusetts have a similar shape. Both these box plots are skewed to the right. You have more variability from the median to the third quartile here than here. And you have this outlier, which is pulling this to the right, this tail. So you have more variability on the right side. Same thing with the Massachusetts dot plot. So Maine and Massachusetts are similar in that they're both skewed to the right. Connecticut, this is roughly symmetric. The median's in the center almost of quartile 1 and 3, and the min and the max go the same distance away from the quartiles, approximately. So my statement here was Maine and Massachusetts box plots are similar in shape, being skewed to the right, while Connecticut is roughly symmetric. I have that comparative word similar, and I've talked about all three shapes. Then you get to center. You can use a concrete value here. Numbers aren't required. I'm going to talk about the median, not the mean. Box plots only show the median. So Massachusetts has the highest median, Maine has the lowest. So I just said that Massachusetts has the highest median and Maine has the lowest median. That means Connecticut's in the middle. I don't need context. I have that in there once. You could put it again if you'd like. Outliers, both Massachusetts and Maine have a high outlier. Now, I'm not going to say possible anymore. I'm not going to say potential. Like, these are outliers. When you see them on box plots, they've run through, they've calculated the fences to see if they're outliers. And remember, for outliers, you don't need a comparative word. You're just going to list if there are outliers. And you do not need to say that Connecticut has none. All right. Moving on to page 5 of the lesson. Standard deviation is a measure of variability. So it's going to, when we talk about VSCO, you're going to potentially talk about it for the variability. It's just the typical distance from a data point away from the mean. Notice I'm not talking about median anymore like I was with box plots. There's this fancy formula. This is for sample standard deviation. Basically, it's just the sum of each value minus the mean squared. You're summing those up, taking the square root of that average, essentially. You don't need to know the formula. What I really need you to know is it's a measure of variation, and it's your typical distance away from the mean. And we'll get into something a little more concrete in the lesson in a minute here. So in this next question, there's 3 histograms comparing IQ scores. Which histogram has the smallest standard deviation? Justify your response. So what I'd say now is pause the video, figure out which one has the least or the smallest standard deviation and why, and then come back to the video and see me explain it. So here, number 1 has the least variability because all of the data is clustered between 80 and 120. You could see it's a little more spread out in histogram 2. In histogram 3, it's even more spread out or more variable. So 1 has the small standard deviation, 2 would be the middle, 3 would be the most variable or the highest standard deviation. All right, on the bottom, same thing. Can you pause the video, do the bottom multiple choice question, and then come on back and have me walk through it. Largest standard deviation. You are thinking in terms of distance away from the mean, typical distance away from the mean. So you'll notice in C and E, well, let's talk about C first. This looks roughly symmetric, if not perfectly symmetric. the mean would be in the center here, and most of the data is towards the mean. In part A and B, these distributions are skewed. In A, the distribution is skewed right. In B, it's skewed to the left. So the mean is probably going to be somewhere towards the middle, maybe here. But most of the data is going to be relatively somewhat close. Same thing on B. The mean might be like in this interval, but you have a lot of the data around the mean. E is definitely spread out. The mean is going to be in the center. You have some data values in the center. You have some far away. But D is the best answer. It's definitely perfectly symmetrical. So the mean would be in the middle here of the distribution. And most of the data is far away from the mean on the low end or the high end. So most of the data being far away from the mean is going to increase the standard deviation. So that's going to have the most variability in it. All right, moving on. So what I'd like for you to do is use your calculator here so you can get comfortable with some of the features that you're going to need to utilize. So we're looking at arm span for a class of third graders. So if you take your calculator and you go to Stat, Edit. If you have anything in your list, you can clear it out simply by arrowing up, hitting Clear, Enter. And then if I just enter in these values, and then I'm going to go to Stat, Calculate, one variable statistics. And I have my data in list 1. I don't need any frequency list. They didn't give me how many people had 42, 45, so calculate. Mean is going to have a measure of our symbol of X bar. So that's the mean. And median, if you scroll down, is going to be listed there as well. So this gives you the mean and the median. Those are two measures of center, mean and median. And then for standard deviation, there's two different standard deviations. We'll talk more about those later in the course. Here, I just want you to give sigma. That's this symbol, that Greek letter, sigma. And that's 3.26. The interquartile range is quartile 3 minus quartile 1. So I'm just subtracting those two values. So the middle 50% of the data is separated by 6.5 inches. And the range is simply the max minus the min. It's a specific number. Okay, so they get a new student to the class who has an arm span of 65 inches. We want to recalculate this. So you can go back to Stat, Edit, and you can add in that 65. Then you can run through Stat, Calculate, one variable statistics, and you can calculate all of these measures again. So you'll see the mean there, the median 45.5. I could get the IQR, and I can get the range using the max and the min. So there are those values. So what I'd like you to do is read the question here and then try to answer that and pause the video and then come back and I will explain it. So which measure of center, there's two options, mean or median, is resistant. So I really want to look at what changed. The mean went from 43.6 up to 47. The median went from 45 to 45.5. So the mean definitely changed more. That doesn't appear like it's resisting the addition to that 65 because it changed so much. So the median is what's resistant. And then for the variation, standard deviation was 3.2. Now it's 8.5. That's a huge increase. The interquartile range went from 6.5 to 5, slight decrease. And the range went from 7 to 27. So that obviously was a huge impact. So the IQR, well, it did change. It changed slightly compared to the standard deviation and the range. So the median and the interquartile range are resistant. Essentially, if you want to look at why, I'll show you. So if I list the data least to greatest, 38. and I find the median, it's 45. Now I have this other data point, 65, this new student, and I find the median, it would be the average of those two numbers. I could put 10,000 here. It's still going to be the average of those two numbers. The IQR is very similar. Once you find the median, you're finding the middle of the lower half of the data, the middle of the upper half, and subtracting the two. So that's why the median and the IQR are resistant to skewness or potential outliers, because they deal with the order of the numbers. So if you put a huge number on the end or the beginning, maybe it slightly changes those. But mean is influenced by all of, you add these all up and divide by how many there are. Range, max minus min. So if you change those, there's going to be a huge difference. Standard deviation, remember, is the average distance from the mean, and it needs every data point. So if we throw in potential outlier or an outlier, it's going to be affected by that. So to summarize, if you have a skewed distribution, you're going to be using median for the measure of center. And for spread or variability, you're going to be using the interquartile range because they're resistant to skewness and outliers. You don't have to have outliers if there's any skew. All right. So this is just a lot of summarizing here. I highlighted some things. I'm going to talk through this. Measures of center, there's two, mean and median. We use mean if we have a symmetric distribution, and median if we have a skewed distribution. Variability or spread. So this, when we're thinking about VSCO, this is what we're talking about, center and variability here. There's three measures of variability. Range, that's what we used last class, like, oh, it varies from 0 to 20. We were kind of using that. Range is technically a number. We're really hardly ever going to use range because it only takes into account two data points. Standard deviation, it's the typical distance from a value to the mean. If you want to describe it, the context typically varies by whatever the standard deviation is from the mean. So say the number of minutes it takes before you can talk fluently after eating a ghost pepper, perhaps, is maybe the average is 10 minutes for people and the standard deviation is 2 minutes. So that means that for the interpreting that 2 minutes, on average, people typically take 2 minutes, or the amount of time to speak fluently after eating a ghost pepper typically varies by 2 minutes from the mean of 10 minutes. That's essentially how you would describe standard deviation. Interquartile range, it's the variation in the middle, 50%, and that's one of the two formulas that you need to know. Okay, appropriate measures of center and variability. If you have a, if you're going to use the mean and standard deviation, if you have, hold on, I lost my train of thought. You're going to use the mean and standard deviation if you have symmetric data. The reason is they take into account every single data point. And you're going to use the median and IQR if you have skewed data for the center and the variability, because they are resistant to that skewness. All right, last thing here. When we're talking about how the shape of a distribution impacts the mean versus the median, if you have a distribution that's skewed to the left, these lower data points are going to pull down the mean, because remember, the mean is not resistant. So you can picture like a little person here pulling this, like it's a string, and they're pulling on that. They're pulling the mean down. So if the distribution is skewed left, the mean is less than the median. If the distribution is roughly symmetric, the mean and the median are about the same. And if the distribution is skewed right, now this person is pulling to the right, or those upper values are going to pull the mean up because it's not resistant. So that's what this is showing here. All right, that's the end of part one. I'll make a part two for the rest of the lesson.